Hello, my name is Jim Cullafello, and I'm the Vice Dean of Academic and Student Affairs at the Ira A. Fulton Schools of Engineering at Arizona State University. It's my pleasure to welcome you to our National Academy of Engineering Grand Challenges for Engineering Speaker Series, hosted by ASU and sponsored by the Kern Entrepreneurial Engineering Network. This engaging speaker series will focus on the 14 Grand Challenges for Engineering in the 21st Century. Esteemed speakers from across the nation will be sharing their expertise on these grand challenges and answering your questions. We are proud to be a part of the NAE Grand Challenge Scholars Program, preparing graduates to address these challenges. It's my pleasure now to introduce Dr. Ramakrishna, the Director of the National Academy of Engineering Grand Challenge Scholars Program Network, to share his welcome.
Hello, my name is Ramakrishna and I am the Director of the National Academy of Engineering's Grand Challenges Scholars Program Network. The NAE Grand Challenges for Engineering, identified in 2008 by a committee of the National Academy of Engineering, are 14 critical global challenges for engineering in the 21st century, united by the mission of continuing life on the planet and making the world more sustainable, more healthy, more secure, and more joyful. The Grand Challenges Scholars Program, inspired by the NAE Grand Challenges, reflect the rapidly evolving nature of engineering education. The goal of the program is to prepare engineers who not only have the necessary technical skills, but also the cross-disciplinary knowledge, entrepreneurial spirit, the global multicultural perspective, and a sense of societal mission needed to meet the global grand challenges facing humankind in the 21st century. As of November 2018, 65 institutions across the US and around the world have implemented this innovative educational program, and nearly 100 are getting ready to join the consortium of GCSP schools. We at the National Academy of Engineering are thrilled that Arizona State University has taken the initiative to organize this series of presentations that will highlight each of the 14 NAE Grand Challenges and provide this valuable resource not only to its own students and faculty, but to students and faculty from around the world. On behalf of NAE, I'd like to thank ASU and the Kern Foundation for making the presentation series possible. I'm eagerly looking forward to following how this series impacts and inspires the next generation to create solutions to our society's most daunting problems. Our best wishes for a successful series, and thank you very much.
Welcome everybody, my name is Ryan Muth. I'm a lecturer at the Ira A. Fulton Schools of Engineering here at ASU, and today I'll be your moderator for this Grand Challenges Speaker Series event. I'd like to welcome you and thank you all for attending. Today, Dennis Bonilla will speak about the grand challenges of enhancing virtual reality within the theme of joy of living. After his presentation, you guys will have a chance to answer your questions, and I'll be ask questions of Mr. Bonilla, and I'll have a few of my own. Dennis Bonilla is the Chief Technology Officer at Baltu Studios. With 20 years of technology experience, Mr. Bonilla has helped create data visualization software and decision support systems for NASA and other U.S. agencies, and has served in roles supporting committees advising U.S. President Barack Obama about options for future human spaceflight. At Baltu Studios, Dennis is creating immersive tools to enhance human capabilities. Baltu Studios leverages AR, VR, and XR to help companies understand and solve complex problems. Dennis has spoken on space and science at South by Southwest Interactive, IGN HQ, Phoenix Comic-Con, the ONA Annual Conference, and Star Wars Celebration, and has collaborated with the Center for Science and Imagination on projects exploring science fiction and the future. Dennis also co-hosts the popular monthly Phoenix VR for Good meetup. Dennis.
Good morning, everybody. So let's get started. So the title of this particular presentation is "Learn to Not Fear the Dragon," and I'll start to explain what the dragon is. 6 years old, I walk into the National Air and Space Museum, and I'm completely dumbfounded by the spectacular array of aerospace accomplishments that human beings have been able to complete over the last 100 years. One of the things that's kind of interesting, though, is that as a 6-year-old that loves to ask questions, I'm also horrified because I'm thinking, there's no way I could possibly do any of this stuff. And so the dragon for me at that time is the idea that I don't know if I'm smart enough, right? As a 6-year-old, as a 14-year-old, as an 18-year-old, how do you even begin to accomplish anything that looks like this? So what's kind of cool about dragons is that people attack these problems in different ways, right? Oftentimes collaboratively, sometimes on their own. There are often naysayers that say that these problems are impossible. In this case, this particular person became a dragon, right? Like this is the Dragon capsule for SpaceX. And so what's kind of interesting here is that there are different ways of approaching problems, and I just kind of wanted to express that the dragon, that particular problem that you're approaching, often doesn't have a single solution. There are multiple avenues to accomplishing a task. Why? Because, why the dragon? Fear makes the wolf look bigger, right? Like that's often the case. The problem is less technical often than you think it is. It's more about whether you have enough time or enough money to solve that problem. And so if you think about things that way, it kind of starts to take away that fear that you're not good enough or you can't accomplish it. Why? Because you should be thinking about not accomplishing it on your own, but with the help of others. So for me, when I had that epiphany, that occurred probably in my early 20s, I started thinking about all these doorways that appeared to be shut at one point. They now look different to me. Once I had that moment, it was like, these aren't impossible things. It's just a matter of finding out, what super friends I can make to actually start solving these problems. And so those doorways start to then look like doorways that are open as opposed to ones that are closed. And so for myself, it's getting over that fear. It was getting over that fear of not being good enough, of not knowing how to do it, not having the technical capabilities. You study, you learn, you get to where you need to go. And oftentimes it's about that path to getting there as opposed to just the problem, because what you'll find is that once you step through that doorway and you decide you're willing to tackle that particular complex problem, that you've come up with solutions for a bunch of other problems, right? And then other doorways start to show up. So this is a piece of software that I helped develop in 2005. This is pretty crazy. This was like 12 different simulators that needed to talk to one another at NASA. And everybody was having kind of a hard time figuring out how that was gonna get solved. And so I had the pleasure of working with a group of about 7 or 8 people that ideated kind of really radically around how to solve that problem. And what we ended up doing, kind of, again, despite the naysayers, is we gutted a video game engine. So we gutted this video game engine, and we figured out basically how to pipe this simulation data into the video game engine. And suddenly all this data was available to hundreds of other engineers. One of the proudest moments I have in my career is actually walking into a room at Johnson Space Center, and there's like 50 scientists and engineers, like legit rocket scientists, working in this system. This was called the Distributed Observer Network. It blows your mind, and like, oh my God, if we can do this, then we can do all kinds of other stuff. What's interesting about this particular problem is that it was one really about collaboration. So who are the people that we're solving the problem for? What is actually the problem that they have? Identifying that. So in the kind of entrepreneurial spirit, oftentimes clients will come to you and they think that the problem looks one way, but it actually might be a different problem altogether. And it's having the patience to hear them out, to understand and strategize with them. In this case, I'll tell you, for NASA, when you're supporting long duration space missions, this is to think about, this support of a mission to Mars or mission to the Moon. They have problems around radiation shielding, right? They have problems around latency, available bandwidth, complexity of data. Those are the kinds of things that they use this particular piece of software to solve for. This is a different project that came a few years later, also a visualization project, and it was that there was this prison that the Department of Justice wanted to visualize. And the problem with visualizing this particular prison is that it was like 120 years old. So there's no CAD data. It's been modified for 100 years. It doesn't look like anything on paper anywhere. And so they had a training exercise that they do every year. And in this case, it was 3 months until the training exercise, and they really, really wanted to have some kind of three-dimensional map of this particular prison. And so I was, this is kind of interesting, I was actually reading some stuff that Hollywood was doing for a major motion picture and how they had used LiDAR technology to scan downtown Los Angeles before they blew it up in the movie. And so I was thinking, you know, that's kind of a novel use case there. Could we do something? It's not the right kind of data that we need for this particular project, but could we do something similar to that? So we actually reached out to a company that uses lasers to scan pipes for oil and gas and large industrial installations. And so they're used to like the complexity of having to scan really crazy looking shapes. And so we said, hey, is this the kind of thing that you guys would do? And they were like, well, that's pretty novel use of our tech, but I think we could do it. So we went all together and ended up scanning it. We had some coworkers that, you know, kind of went up there during a blizzard, and you know, that's not creepy. And actually, we're able to scan this prison. There were no inmates in the prison. It's abandoned for that kind of use, but it's still used for training. And so in this case, what was interesting is actually having to develop a way of transferring that laser data, that point cloud data, into reusable three-dimensional assets. And that was the core of the problem. That probably took, you know, it was 3 months to complete the project, but that core problem probably only took about 3 weeks to think through. And it took a lot of people in a room thinking, how do we cut this up? How do we think about this? How do we make this more fluid than what it's been before? What was interesting was that then also provided that company with a visualization, with a three-dimensional visualization of their products, right? Of their assets, of things that they could produce for customers. So suddenly it was an asset to them, being able to visualize and walk through, because you could actually walk through this particular installation with a, you know, it was a virtual environment that you could walk through on a computer. So yeah, really the problem with this was ideating around how do other data sets, how can you almost like a universal translator, how can you translate it into a thing that you can use later? And that's often really what you're doing. You got a data set somewhere that you got to convert into some kind of insight, and how do you translate that? So this was a different problem. This was actually done for the United Nations and USC's Shoah Foundation, and it is the telling of a Holocaust survivor's story in a photorealistic virtual reality environment. This is something that was shown at Tribeca, I believe, in 2017. And so I got a call. It was like amazing visual effects companies, the best visual effects companies in the world were working on this, and they were having one particular problem. It was not fitting together in a certain way. And they had heard some of the work that I had done previously, and so they said, you know, this is a challenge. We have only a few weeks to solve this thing. Are you up for it? I said, yeah, sure. And so we started working on it. And here's something kind of interesting about this problem. The problem itself, from a technical standpoint, wasn't super complicated. And so for you engineers out there, we had photogrammetric 3D hyperrealistic high polygon models in a stereoscopic video. So that's what we're doing. We're essentially compositing those two into a VR environment. But that wasn't the problem. The first 2 days, we couldn't stop crying. Why? Because it's very emotional data, right? You're watching it, you're having to see whether it composited correctly, whether you were able to make it work. And you're essentially working inside of a headset, inside of a concentration camp. So this is actually an emotional problem. It's not even like a technical one. We know how to solve it, but how do you get through the emotional aspects of actually building this thing? And so one of the developers actually, a few days after came in, the lead developer I was working with, he came in and he said, we got to do this. And he, after crying for a couple of days, he said, we got to do this. And I said, what changed? What happened? And he said, no, I was thinking about my kids. This can't ever happen again. Like, it's up to us to do this. And so think about that, like as a technical person, as an engineer, having a philosophical issue, trying to get through the horrendous byproduct of genocide, right? And this is just me in VR experiencing this. Not in a million years did I ever think I'd be like walking through the basement of a prison trying to scan it with a laser. Never did I think I was going to be like inside of a concentration camp trying to composite a thing so that it could be shown to Spielberg and George Lucas in 2 weeks. Like that's crazy. That's pretty amazing. But what I want to get at is that the right teams can almost make anything happen. And so getting over the idea that you're not capable, you might need some work on a particular thing. You might need to do some homework on a particular thing, homework that somebody else has already done. And so you can actually lean on them. And so what's the thing that they need support for? And thinking about problems in that way actually changes those challenges. It's a kind of a dynamic way of not approaching a thing as monolithically, right? It's not a big problem. It's probably a bunch of little problems we can solve. So what I do now is I co-founded a company with some friends called Baltu Studios. And so what we do is we focus on developing cutting edge tools, right? Using immersive tech. We're a software development company, but we really love AR and VR. We think that there's something happening there that hasn't been happening in computing for a while. And so there's opportunity to create really radical new solutions for not only new data, but old data. How do we rethink old data? And so what we do is we collaborate with universities, research labs, and sensor developers, right? Because for us, what's really interesting is learning how these new things work. Like VR is cool as a tech, AR is cool as a tech, but like, what if you could like see through walls? Like, what if you could, I don't know, look underwater? What if you could recreate the past? That's not our expertise. We're not subject matter experts around that kind of information, but we reach out and try to find out problems that are interesting, and maybe VR or AR is a novel way of approaching those problems. So you get to work on a lot of really fun, different kinds of things. So as far as collaborating, so we've been doing some work with ASU across a few different labs, and one of which is the ETX program. And ETX creates all this really awesome curriculum, right? I think they collaborate with NASA, and they get some funding through NASA to create curriculum for like high school students, right? High school and middle schoolers. And they really want to be able to describe really kind of interesting celestial data, right? So in this case, it's visualizing the position the moon needs to be in to show a particular phase. And so they had already written that curriculum. I wouldn't know how to write that curriculum, but they did. And they said, hey, listen, so what we would like some support on, we'd like to actually pull that curriculum outside of the monitor and put it like into a kid's hands. Like, how might you approach that problem? And so we collaborated, and we actually built this interactive AR application where you can actually touch the screen, and floating in front of you is the Earth, the moon, and the sun. And you can, as you change the position of the moon, you can actually see its phases change, right? And this data is coming directly, like that's a series of photographs on the bottom left corner taken and processed through NASA Goddard, which is up in Maryland. So this is like NASA data being given to middle schoolers to understand, and they get it. Like there's the research that they're doing right now at ETX is around retention. So this is a novel way of showing that particular curriculum, but is it actually helping those students retain that information? So that's what they're looking at. That's interesting to us, because then we can go back to our clients and say, listen, here's an interesting application for education for middle schoolers, and here's some data actually showing that this is a better way to show that information. And so speaking of the sun, this is kind of interesting. This is a composite taken through NASA's Solar Dynamics Observatory, which is like these orbiting satellite systems, or satellites. And what they do is they take images of the sun I believe, every 12 seconds in 10 different wavelengths. So think about the astronomical amount of data that is, right? There's like a ton of data. And so what they did is they composited just 23 of those images across a 1 year span of time. So this is a composite of 23 images that were taken between 2015 and 2016. And so this is temporal data, right? This is data that has a timestamp. And as you composite that data together, you start to actually see trends, right? Like, wow, there are solar flares that are occurring in particular spots across the sun. If you had a single one of those images, you wouldn't be able to see that trend. It's only by stacking those images that you can now recognize what is happening on the surface of the sun. And that's pretty powerful information to have. So for us, it's like, we look at this, I didn't have anything to do with creating this, but we look at something like this and we go, well, that's super freaking cool. Like, so temporal data. So if we had time-stamped data of some kind, 3-dimensional image, audio, radio frequency, whatever it might be, and we composited it, would there be a way to leverage AR, VR to actually explore these trends? Like, how do people move throughout a city? How do they eat? How do they accomplish certain problems? Maybe that's a way of visualizing something that will provide insight for a lot of different industries, right? Because a lot of different industries actually take in temporal data. They produce temporal data, like medical, right? So this is kind of interesting. This is a cross section, right? This is a scan. You've probably all seen something like this at some point. It's a cross section of a human skull, right? So it's like a person. They've gone into an MRI machine and it's scanned them and it's done these different slices. But this is it's kind of dry, right? Like as a client or as a patient, this is very hard to decipher. So what we're thinking of when we're solving these kinds of problems is the human element. Like, what's a way of showing this data that might actually make sense to all of us, right? So what if we actually composited them? What if we put them all back together again and had them 3-dimensionally represented to you? Like, you know, God forbid you have like a tumor or something, right? Like, you're gonna wanna know where that thing is, right? How many of us have actually performed any kind of like brain surgery? Like, we don't know how that works. But if you show somebody where something is in your head and how a doctor might attack that particular problem, it's going to put a lot more patients at ease. They're going to have a better understanding of how those procedures occur and why they even have to, right? Like, I don't want somebody drilling my head if they don't have to, but if I can see why they have to, well, then I've created context, right? I've now gained some context around that particular problem. And there's a human element to that. The problem is the tumor in the head, but there's another problem there, which is how do you explain that to other human beings? Like, how do you relate that? And so as we think about complex systems, what other complex systems, right, have thousands of discrete components like the brain, producing tons of data every single day, right? The most interesting kind of use case that we've been thinking about around those kind of data sets, large temporal data sets, and really complex systems, well, cities produce that kind of information, right? And if we think about image stacking, or if we think about 3-dimensional information, what kind of data can we extract from a city that we've previously been unable to see before, right? Like how does pollution move through a city? How do people move through a city? How does traffic move through a city? How could we change that traffic? How do I as an individual move through a city? Could I move through a city in a way that allows me to meet more interesting people? Like, could I move through a city that allows me to meet people that will help me solve other problems? Can I move through a city that, I don't know, reduces my cravings during the day? Like, I don't know, but these are the kinds of problems where there's a human element and there are large data sets that we can extrapolate and derive insight from. And so I wanted you to think about that. And I kind of wanted to take a moment, kind of to jump out of all this techie stuff and tell you that you need to read. And you need to read a lot. And you need to not ignore reading. And the reason I say that is because many of the solutions and many of the teams that I've worked with, the way things have kind of flourished, like the serendipitous moment, often comes from something completely unrelated to the task at hand, right? It's usually less about how do we visualize that tumor and more about, wow, you know, I read this really great short story that was published in the 1960s, and like, wow, there was a really emotional impact there. And I started to visualize what they were explaining because it never existed before. I'm a big proponent of science fiction, right? Like really good science fiction is just like mind-bogglingly good because it allows me to actually ideate and build against. Reading, and not just in your field, right? Like reading what designers are thinking about or what artists or musicians are thinking about, medical professionals. I'm not a doctor. Thinking about problems in those kinds of ways will give you perspective. And it's often very challenging to start reading, right? Like from a different place, like reading a study, right? Is often really, really dry and difficult, but if you can push through it, you'll usually find some gem in there that you can use later. And don't worry if it's not immediately applicable, because you might find that 2, 3, 6 months, 18 months later, it's the thing that you totally needed. So that's my kind of request of you as you're thinking about the future, to not forget about reading, right? Because you'll graduate and you'll move on, you'll do other things, but the studying doesn't stop ever. I'm sorry, but like it goes on forever. And so I co-host a meetup that we've been doing for the last couple of years here in Phoenix, over at the Tempe History Museum, which is called Phoenix VR for Good. And so what's really cool about Phoenix VR for Good is that we get, pretty decent size of people. There's anywhere between 30 and 60 people show up every week or every month. And they're from all different kinds of industries, right? They're neuroscientists, they're engineers, they're architects, they're writers, and they come in and we get really healthy, just vibrant conversations. Last night we did one around mindfulness and meditation. So think about that. I own an AR VR company, and I'm like trying to host a thing where there's like everybody's doing yoga. Like it was pretty whacked out, but it was cool. It was a lot of fun. And so I learned something. And so part of the trick around doing things like this is that this is a way in which the company finds collaborators. Because if you're willing to go to a thing that's called Phoenix VR for Good, well, then you're probably on the same wavelength that we are, right? And this is why we want to work together. So think about that. Think about people that you can meet and how you can find them. And so what's great also is that when you start to collaborate with people, other people notice, right? Oh, I like working with her, or I like working with them. In this case, Nissan noticed, right? And Nissan actually did a commercial around the meetup. Like, think about that. Like, we're just like in the Tempe History Museum hanging out, doing funky stuff, and like a commercial gets shot. And so there are all these different benefits that are possible from just collaborating. And I want to express to you, I cannot express enough that collaboration is the future. Like that's what you're gonna need to do to solve really complex problems. And finding those teams early, finding the people that you can collaborate with, the people that are open to having their data questioned, or not questioned, but analyzed, is really useful, because we should all be learning all the time from one another. And that's kind of what I wanted to leave you with for this particular presentation. Just kind of go over what we just talked about, what I just kind of ran through. What can we build, right? What are the things that we can conceivably build using immersive technologies? So manufacturing support, right? Giving better context to complex systems, medical personnel and patients, situational awareness, sensitivity training. That's going to be really, really important in the future, right? We've got this global economy. You got to know how to talk to different kinds of people. There's certain sensitivities that we all should have as we relate to one another. Command and control systems, smart cities, autonomous systems, those really super complex day-to-day activities that we can't really gather too much insight from now, but maybe immersive technologies will help us do that. And then finally, temporal data. Any data that is either related to time or is time-stamped is really interesting because you can kind of play with that. There's a functionality to immersive tech that, for lack of a better term, time travel is really interesting in VR. So thinking about those kinds of things. So thank you. Thanks for the time.
Thank you, Mr. Bonilla.
Sure.
That was a great overview of many of the challenges in virtual reality and all of the great opportunities that are available to you guys to help create solutions that create value in society. I hope you all have learned something new about this ground challenge and that it's inspired you to take some action and get involved. For the remainder of the time, we're going to give you, the audience, the opportunity to ask questions of Mr. Bonilla on his work, the field, or anything that you're curious about. If you want to ask Mr. Bonilla a question, you can submit them now. If you're joining us live, you can submit your questions via text message to the phone number that's on the program. And if you're watching via the live stream, you can ask your questions via the chat directly through YouTube. And we're going to do our best to answer as many questions that you have. While you're submitting those, I've got some questions that I'm going to ask, and then we'll get to yours. Okay, so VR was like the next big thing in the 90s, but it kind of disappeared during the 2000s. What happened, and how does that sort of inform the industry as it's developing again now?
Yeah, so that's a question that I've been thinking about this one. It's a question that I'll answer this way. So computers pop up for most home users 1976, 1977. However, computers really started to show up in the 1960s, right? And there's like a 10-year delay. Why? Because it's super expensive. So if you think about VR in that way, what ended up happening is that the companies and organizations that could afford to do VR kept using it, right? So NASA, the Department of Defense, a bunch of research institutions, automotive companies, they continued to use VR. The problem at that time, I think, was that there was just not enough kind of computational power to express the data in the way that most industries wanted to express it. Like right now, we get asked all the time, hey, why can't I talk to the computer? Like I'd love to do that. Well, like, I'm sorry, but we're not totally there yet. So with VR, that kind of happened. There was this, I think, false expectation that suddenly we'd be able to fly through different worlds and do different things. And for some people, we could. And so they kept doing it. And I think what that helps inform us now of is not setting false expectations for the technology, right? Oftentimes people don't even want to put the headset on, right? Because it's heavy and clunky, and so what's going to happen? The headsets are going to have to get lighter, they're going to have to get less expensive, kind of less arduous to deal with. Nobody wants to deal with all these cables, right? And so I think that taking kind of the learnings of early computing and then later VR, in the 90s, and informing us of what the consumer is actually after is going to be very powerful. If you're kind of looking at it, you know that it's not quite all the way cooked yet for certain industries, but for others it's perfectly fine. If you have $1 million room and you have to do a thing in a headset that only costs you $1,000 or $2,000, and you can do the same thing that you need to do in the $1 million room, well then, yeah, go ahead and save the $999,000 to do it.
Awesome. I remember going to like an arcade when I was a teenager, and they had a VR game set up, and it was this huge clunky thing. It cost $1 for like 2 minutes or something like that, and it was terrible. It was the worst investment of my money ever. But
thanks for that happy childhood memory.
Yeah, totally. But it was the expectation. You see the screens, and then you actually experience it, and it was a huge letdown. So what happened in the last 10 years that has sort of brought that back?
Yeah, so actually, cell phones, right?
Okay.
Cell phones. There was a huge breakthrough in portable computational power. Most of us now have essentially many times more computing power in our pocket than we did on our desks in the 1990s. And that happened pretty dang fast. It happened in a matter of like 10 years. All these billions of dollars of investment in portable computational technology and screens, right? Lighter screens, more higher resolution, higher density screens, kind of miniaturization of computing. And as you start to miniaturize that computer, well, suddenly you can kind of fit it in a headset. And that's kind of been the breakthrough moment. There was a Kickstarter that occurred a while back. I know Valve was doing a bunch of research. Valve is one of the largest or most popular game development companies. They were doing a bunch of research. There's kind of independent research occurring all across the world, and there was kind of a convergence point that occurred about 5 or 6 years ago, where it was now possible to create a headset for about $1,000. And so as soon as that happened, everybody started to jump on. And I think another interesting occurrence was Google putting together the cardboard headsets, right? Realizing, hey, we don't need to do much more than have a container for your phone. And that's interesting, but you needed to get to that mobile phone that had enough power to put it into the container.
So VR and AR was basically unknown or like super specialized about 10 years ago. What should we expect to see in the next 5 or 10 years?
Yeah, so like I did my best to kind of try to cover some of the larger industries that are going to be affected sooner rather than later. But I think what we're going to get to is we're going to get to a moment where a ton of what we do is holographic, or it exists in 3-dimensional space. And that, I mean, think about this. Like, think if you had a pair of glasses, right, that could project something the size of this screen behind us as a super high resolution. Why do you need monitors then, right? Think about the disruptive potential of that, just that. And then, so now you can carry a computer, essentially a laptop all the time, and extrapolate on that. If it doesn't have to be flat and is 3-dimensional like I was describing, well then we're going to start to think more 3-dimensionally. So all these industries that really are having a hard time understanding their data sets, they're going to have a different way of looking at them. And so you say which industries or where's it going to happen? It's going to happen everywhere, and it's going to be this tidal wave. Hopefully long enough for my company to see something out of that, but it will be incredibly disruptive. Yeah.
Is there an application or industry of VR and XR and AR that you think is sort of underexplored or underdeveloped?
Yeah. So this one's kind of interesting. I think we're attacking really, really complex data sets and really kind of like visualizing data and doing all kinds of crazy stuff, and that's cool. What about therapy, right? What about what about emotional intelligence? What about EQ data, emotional quotient data? Like, how can we relate to one another better, right? How can we kind of get over our fears? And that's kind of what the theme of the presentation was. But like, how can we approach each other in a more satisfying and more joyful way, right? That's part of the reason we had the meditation and mindfulness meeting last night, right? Like everybody's like, why is this tech guy doing Om in the basement of a building? But it's approaching those problems, which I think don't get enough funding. Like stress and anxiety are big problems in the United States and globally, and I think we should be applying some of these technologies to those problems.
This is a kind of a very different direction. Have you ever experienced VR sickness or anything like that? Yeah, so oftentimes what'll happen is that someone that has an idea, like, either a content creator, or a marketing person, somebody who's really fascinated with the tech, wants to do something. So, what happened in the early, this current generation of technology was that people were saying, oh, you can be anywhere, you can do anything, or you can jump around and fly through space and all this stuff. Well, guess what? Like, locomotion is, the process of moving around in 3-dimensional space. So locomotion, our bodies are not used to being moved without us directing it. So oftentimes what will happen is that you'll have a content creator that is creating the content before even trying VR or using their content. And so that motion sickness often happens because the frame rate is too low.
They're moving your body through 3D, what appears to be 3D space, and you're gonna get sick. I've gotten really, really sick. And it's usually because the person isn't being thoughtful about the experience that they're making.
Interesting. So related to that, convincing VR is about managing human perception, right? Are there design decisions like the one you were just mentioning that tell us about how people perceive the world, and are there like tips and tricks?
Yeah. So embodiment goes a long way, right? If you can show someone that they've got hands and feet and legs and a torso, that's going to go a lot better than like if they exist as like a single wand floating in space. I think there's also this race for photorealism that isn't really necessary to create an emotionally impactful experience. So I think oftentimes somebody that's really kind of getting into this industry, they'll say, well, I want to make a thing that's so real, it'll make someone cry, or it'll make someone laugh, or freak out, or whatever it's going to do. And not about the story, right? So like in movies and books and all kinds of literature, the story is really important. The story of the data, the story that you're trying to tell, the thing that's supposed to be emotionally impactful, that still matters much more than the tech does. Because you can get around the tech. Like there's a way of showing something that isn't photorealistic that's still going to deeply affect someone. So thinking about problems in that way.
Right. Where should a student start if they want to get involved in the AR VR field, especially if they're not a computer science student? And what kind of software or tools would you recommend?
Right. So I'm a huge proponent of like game jams and like game meetups and that kind of thing, because I think the games industry has really been trying to tackle this problem of like making it kind of a democratized technology, like the software. People want to make games all the time, and that's not too different than wanting to make immersive software. They use similar technologies. The two most popular game engines are Unreal's technology, and Unity, and those two are pieces of software now that are kind of like almost like saying Photoshop of the future, right? Like when I'm looking for someone to hire or I'm looking for someone to contract, usually they have to have some expertise in that area. And even if they've done 3D development or if they've done music or whatever it might be, if they've incorporated that into kind of game engine or game type of experience or application, that goes a long way. So like if that's on your resume, or if you've, hey, I've published something, that's a huge win.
It seems like this is a very exciting topic. It's lots of people are talking about it, and we see it in the news an awful lot. Is it used more in applications like the industry, but we don't see it? Like it's not part of our everyday lives yet. What is it limited to research, or is it sort of getting into people's hands?
I think it's the convergence of technology. I don't think it's quite light enough yet. The price points seem right, like around $300. But it's just not exactly what everybody wants yet. And I think that like you're going to have the early adopters, like the techs and the people that are enthusiasts that are going to pick this stuff up. Think about it again, like if we're in 1979, it's still like 5 more years until the Mac shows up. And so like it could be that long until the Mac headset. And I don't mean Apple necessarily, but something sexy, something portable in a way, something that you can show off, because people are going to want to show it off. We're still not quite at that moment yet.
So the personal computer had a big moment when the spreadsheet application came out. That was the killer app. Is there a killer app for VR that you see coming down the pipe?
If I knew, I would be a much wealthier man right now. I think that there are going to be a lot of different ones. I think that we have learned a lot from social, right? Like what to do and what not to do with social media platforms. I think there's going to be a social component. I think that there's going to be something around temporal data or time-based information. For instance, the Notre Dame just burned down, and within 3 or 4 hours of that news being released, a bunch of folks that work in what's called volumetric imaging, so these folks that scan with lasers, all kinds of stuff, immediately said, hey, there are like data sets that have already been gathered of Notre Dame. So like if you were to rebuild it, we have the point clouds. Like we could literally recreate a 3-dimensional model so that the people constructing it could get it to within an nth of what it actually looked like. And that's pretty powerful stuff. So I think you're gonna have things like that you just couldn't do before.
Awesome. What's the favorite project that you've ever worked on?
Oh, favorite project. Favorite project. This is kind of interesting. I would say one of the most impactful for me, one of the ones that I'm proudest of, although I didn't have a huge part in it, was The Last Goodbye, which is the Shoah Foundation's Holocaust story. That was really, really impactful for me. And I would also say that I've worked on some sustainability programs that really kind of went a long way, because you feel like you're contributing in some way to something. And so I think kind of the emotional projects have kind of a wider and more kind of pop culture impact than the, hey, I solved a problem for a particular robotics company or whatever it might be. I would say probably the Holocaust one at this point.
You were talking about photorealism and sort of that push for it. Do you deal with the Uncanny Valley very much, particularly in the Last Goodbye?
Yeah, absolutely. And so for those of you that may not be aware what the Uncanny Valley is as you approach realism, and especially in human avatars or human non-playable characters or representations, the more realistic it gets, the more our brains are observing whether it's real or not. And it's why we kind of get creeped out at mannequins, because there's a point like before basically the illusion of life occurs that the thing looks dead. It looks like a zombie. That's why zombies freak us out. And so that's a problem all the time. Yeah, and so there are ways around it, right? There's like, you could shoot video instead of actually trying to 3D model a thing. You could scan it in a way that the 3D model is convincing enough. Again, you can have an emotional component that kind of softens the impact of the 3D model not being completely photorealistic. So there are strategies. We encounter it all the time.
What sci-fi book or author would you suggest and why?
Science fiction, of course, Ray Bradbury. If you have not read Ray Bradbury, that's near and dear to my heart. Isaac Asimov, kind of the classics. I also really, really love science fiction film. At home, I have a set of movies that if I ever am just kind of sitting down, or if it's a rainy day or whatever it is, it's going to be one of those movies. And I will tell you, the two movies at the top of my list are Akira and Back to the Future. Those are the ones at the top of my list.
Those are excellent choices. What did you think of Ready Player One?
Dystopian future where a single corporation wants to own all of virtual reality. We all live in ghettos that are stacked on top of one another and nobody cares about each other. Not my deal. That's not my thing, man. I think that there's an opportunity to actually teach people that is the wrong path. And I'll give you a little secret that was kind of the most disappointing part. The most disappointing part of that film is that it ends and they have stuff. And they have lots and lots of stuff. And they go, we have so much stuff that we're gonna shut down the Oasis once a week. What about all those people that don't have stuff? Right? You've just now taken their opportunity to escape in this hellacious future. So being thoughtful, making thoughtful decisions, not using it just for fantasy, but for education, for exploration, for communication. Those are ways I think in which the technology can be leveraged. I thought it was okay. I mean, you asked about authors. I forgot to mention William Gibson and Philip K. Dick. Those are amazing too. But I think that Ready Player One was really derivative of kind of William Gibson's work, and so I think going back to kind of the originators is more interesting.
Google Glass seemed to be a really good AR device. Why do you think it failed?
Much like VR, I think that rumors of its death have been greatly exaggerated. I wouldn't be surprised if you see Google slowly chipping away at what is conceivably a very powerful tool for them to extract world data, right? Like Facebook's gonna do it, Google's gonna do it, Apple's eventually gonna do it, Magic Leap is doing it right now. How do you extract data from the real world? And there's no way in my mind that Google would give that up.
So you manage teams of very smart people working on very tight timelines. How do you manage the crunch time? How do you keep them motivated?
So we tried for there not to be crunch times, right? Like agile methodology. You use sprints. You accept that you can only get a certain amount of work done within a certain period of time. You're very realistic about those deadlines. You communicate them back to the clients, and you hire people that you hope are inspired by the work that they're doing. Like if your people are bored, or if they're not enthused, or they're not interested, or they're, if they think it's a pain, well, you're not going to get good work, and it's going to be almost impossible to convince them otherwise. I also think it's good to kind of include joy in day-to-day activities, right? Like it's okay to be goofy. It's okay to laugh, or it's okay to kind of riff on things, as long as you aren't wasting a ton of time. Like there's opportunity there, and oftentimes in those goofy moments, you'll find something interesting. Like, oh, I just said that. I hadn't thought to say that before because I was holding back. Hey, can we use that? Yeah, we can totally use that. And then you use it.
So related to that, is there a set of skills or processes that are, I don't want to say non-technical, that students should learn to help make sort of their career paths better? I
think it's important to be comfortable speaking, right? I was not comfortable speaking for a very, very long time. And it just so happened that there was an opportunity that showed up. It was a kind of a 5-minute, just kind of lightning conversation. And I had to go through like 30 slides or something like that in 5 minutes. I hadn't done anything like that before. And it was in front of like 400 people. And I submitted and it got accepted, and I freaked out. Like I didn't know what I was gonna do. In the first one, I sucked. Like it was horrible. Like it was no good. And friends that came were like, no, it was okay. Like I was like, oh no, I totally screwed that up. But I got really good advice from a friend of mine, and she said, listen, you went back and you looked at notes while you were speaking. That's not how you normally talk. And I had a moment here where I actually was gonna read notes, and I started worrying about the presentation. I was like, no, let it go. It's like, you know what the slides are, like just talk to them. So the second time I submitted again, fortunately was accepted. And it was about talking about the future, and I love talking about the future. And I rocked it. And then it was like, you have the self-confidence. There are 400 people, and suddenly everybody's like giving you their business card. Hey, can we chat? Can we go to lunch? Can we do a thing? Like, I think you're interesting. This is kind of wild. And you meet interesting people. And so I would say, get comfortable talking, get comfortable expressing yourself, explaining what it is that you do. Don't be scared about some mode of self-promotion. Don't go nuts with it. Like you're not just a brand. Like you're a human being. So be a human being, but like try to define a story, because if you don't tell your story, nobody else is gonna, or somebody will, and they'll get it wrong.
So how important is haptic feedback and systems like haptics, if you're familiar with them? Yeah,
so haptic feedback, I think the more you've got kind of immersive technologies, so smell is really, really powerful. I don't know how many of you have done like Soarin' at Disneyland. So Soarin' does this whole thing where like you're in a chair and you're looking at a gigantic screen. There's no headset, there's no even like massive haptic feedback. I mean, you're swinging in this chair, but there's a scene in which you're flying over the savannah, and you can smell grass. And I remember just like being completely enthused and going, "That's grass! Like that's totally grass!" And it's grass. It's like, who cares? But I felt like I was there. So I think the more haptic feedback, smell, anything that kind of that taste, right? Like we haven't even. Who's talked about taste in VR yet? Like that's going to be super powerful. Like any way to kind of let those senses feel like they're doing something is going to be incredibly powerful.
So we're getting near the end of the time here, and I'd like to return to how you ended your talk with the call to action and how to get others involved. I'm sure you've inspired some people to get involved in this industry. How can students or others get involved, and what can they do to contribute to addressing some of the challenges you talked about?
Yeah, I would say if you are interested in AR and VR, I wouldn't just, unless you're interested in like developing the tech, like the screens and the sensors and those kinds of things. If you're actually trying to solve a problem, I would go to those subject matter experts and I would say, hey, is there an opportunity here? Is there something I could help you with? Like, can we talk a little bit about what that particular problem is? Maybe it is VR, maybe it's not. But really going to the source of those problems rather than kind of inferring what the solution is really useful. Like getting client feedback, being able to ask and listen. Because oftentimes, half the solution is just listening to what someone is explaining. As I was saying before, the problems are often either communication or workflow. They are technical, but it's like, oh, that data set needs to be handed off in a different way. And just being able to sit down and listen to somebody explain how it's currently handed off and understanding that it needs to be modified or updated, that's useful.
Right, so as engineers, sometimes we get too excited about the technology itself,
yeah,
right?
I know, yeah.
Yeah. Awesome. I think that's all the time we have for today's event. Thank you for joining us. This last event, this series for the semester. Please watch our website for future events in the fall and spring in this NAE Grand Challenges speaker series. Please join me in thanking Mr. Bonilla again for a great talk this morning.